configuring JavaServer Faces applications. The process of building and deploying simple JavaServer Faces applications has been described in earlier chapters of this tutorial. When you create large and complex applications, however, various additional configuration tasks are required. These tasks include the following: registering back-end objects with the application so that all parts of the application have access to them. Configuring backing beans and model beans so that they are instantiated with the proper values when a page makes reference to them. Defining navigation rules for each of the pages in the application so that the application has a smooth page flow, if non-default navigation is needed. Packaging the application to include all the pages, resources, and other files so that the application can be deployed on any compliant container. The following topics are addressed here: using annotations to configure managed beans application configuration resource file configuring beans registering custom error messages registering custom localized static text using default validators configuring navigation rules basic requirements of a JavaServer Faces application using annotations to configure managed beans. JavaServer Faces support for bean annotations has been introduced in Chapter 4, JavaServer Faces Technology. Bean annotations can be used for configuring JavaServer Faces applications. The Managed Bean JavaX Faces Bean Managed Bean annotation in a class automatically registers that class as a managed bean class with a server runtime. Such a registered managed bean does not need managed bean configuration entries in the application configuration resource file. An example of using the managed bean annotation on a class is as follows: managed bean session scope public class DukesDay. The above code snippet shows a bean that is managed by the JavaServer Faces implementation and is available for the length of that session. You do not need to configure the managed bean instance in the Faces config XML file. In effect, it is an alternative to the application configuration resource file approach and reduces the task of configuring managed beans. You can also define the scope of the managed bean within the class file, as shown in the above example. You can annotate beans with request, session, or application scope, but not view scope. All classes will be scanned for annotations at startup unless the Faces config element in the Faces config XML file has the metadata complete attribute set to true. Annotations are also available for other artifacts such as components, converters, validators, and renderers to be used in place of application configuration resource file entries. They are discussed, along with registration of custom listeners, custom validators, and custom converters, in Chapter 14, Creating Custom UI Components. Using Managed Bean Scopes. You can use annotations to define the scope in which the bean will be stored. You can specify one of the following scopes for a bean class. Application. Application scoped. Application scope persists across all users' interactions with a web application. Session. Session scoped. Session scope persists across multiple HTTP requests in a web application. View. View scoped. View scope persists during a user's interaction with a single page view of a web application. Request. Request scoped. Request scope persists during a single HTTP request in a web application. None. None scoped. Indicates a scope is not defined for the application. Custom. Custom scoped. A user-defined, non-standard scope. Its value must be configured as a map. Custom scopes are used infrequently. You may want to use none scope when a managed bean references another managed bean. The second bean should not be in a scope. None scoped if it is supposed to be created only when it is referenced. If you define a bean as none scoped, the bean is instantiated anew each time that it is referenced, and so it does not get saved in any scope. If your managed bean takes part in a single HTTP request, you should define the bean with a request scope. If you place the bean in session or application scope instead, the bean would need to take precautions to ensure thread safety because component instances depend on running inside of a single thread. If you are configuring a bean that allows attributes to be associated with a view, you can use the view scope. The attributes persist until the user has navigated to the next view. Eager application scoped beans. Managed beans are lazily instantiated. That is, that they are instantiated when a request is made from the application. To force an application scoped bean to be instantiated and placed in the application scope as soon as the application is started and before any request is made, the eager attribute of the managed bean should be set to true as shown in the following example. Managed bean eager equal true. Application scoped. Application configuration resource file. JavaServer Faces technology provides a portable configuration format as an XML document for configuring application resources. One or more XML documents, called application configuration resource files, may use this format to register and configure objects and resources, and to define navigation rules for applications. An application configuration resource file is usually named Faces-config. XML. You need an application configuration resource file in the following cases: to specify configuration elements for your application that are not available through managed bean annotations, such as localized messages and navigation rules. To override managed bean annotations when the application is deployed, the application configuration resource file must be valid against the XML schema located at http java sun.com XML NS JavaBeans webFaces-config 20 XSD. In addition, each file must include the following information, in the following order: the XML version number, usually with an encoding attribute. XML version equal 1. 0 encoding equal UTF-8. A Faces-config tag enclosing all the other declarations. Faces-config version equal 2. 0 XMLNS equal HTTP Java sun.com XML NS JavaBeans XMLNS G equal HTTP W3 org 2001 XMLSCHEMA instance G schema location equal HTTP Java sun.com XML NS JavaBeans HTTP Java sun.com XML NS JavaBeans webFaces-config 20 XSD Faces-config. You can have more than one application configuration resource file for an application. The JavaServer Faces implementation finds the configuration file or files by looking for the following: a resource named beta-inf Faces-config XML in any of the jar files in the web applications, webinf lib directory, and in parent class loaders. If a resource with this name exists, it is loaded as a configuration resource. This method is practical for a packaged library containing some components and renderers. In addition, any file with a name that ends in Faces-config XML is also considered a configuration resource and is loaded as such. A context initialization parameter, JavaX, Faces, application, config files, in your web deployment descriptor file that specifies one or more comma-delimited paths to multiple configuration files for your web application. This method is most often used for enterprise-scale applications that delegate to separate groups the responsibility for maintaining the file for each portion of a big application. A resource named Faces-config XML in the webinf directory of your application. Simple web applications make their configuration files available in this way. To access the resources registered with the application, you can use an instance of the application class, which is automatically created for each application. The application instance acts as a centralized factory for resources that are defined in the XML file. When an application starts up, the JavaServer Faces implementation creates a single instance of the application class and configures it with the information that you provided in the application configuration resource file. Ordering of application configuration resource files. Because JavaServer Faces technology allows the use of multiple application configuration resource files stored in different locations, the order in which they are loaded by the implementation becomes important in certain situations, for example, when using application-level objects. This order can be defined through an ordering element and its sub-elements in the application configuration resource file itself. The ordering of application configuration resource files can be absolute or relative. Absolute ordering is defined by an absolute ordering element in the file. With absolute ordering, the user specifies the order in which application configuration resource files will be loaded. The following example shows an entry for absolute ordering. File myFacesConfig. XML. FacesConfig. Name. myJSF. Name. Absolute ordering. Name. A. Name. Name. B. Name. Name. C. Name. Absolute ordering. FacesConfig. In this example, A, B, and C are different application configuration resource files and are to be loaded in the listed order. If there is an absolute ordering element in the file, only the files listed by the sub-element name are processed. To process any other application configuration resource files, an other sub-element is required. In the absence of the other sub-element, all other unlisted files will be ignored at load time. Relative ordering is defined by an ordering element and its sub-elements before and after. With relative ordering, the order in which application configuration resource files will be loaded is calculated by considering ordering entries from the different files. The following example shows some of these considerations. In the following example, config A, config B, and config C are different application configuration resource files. File config A contains the following elements. FacesConfig, name. Config A. Name, ordering, before, name. Config B. Name, before, ordering. FacesConfig. File config B not shown here does not contain any ordering elements. File config C contains the following elements. FacesConfig, name. Config C. Name, ordering, after, name. Config B. Name, after, ordering. FacesConfig. Based on the before sub-element entry, file config A will be loaded before the config B file. Based on the after sub-element entry, file config C will be loaded after the config B file. In addition, a sub-element others can also be nested within the before and after sub-elements. If the others element is present, the file may receive highest or lowest preference among both listed and unlisted configuration files. If an ordering element is not present in an application configuration file, then that file will receive the lowest order when being loaded, compared to the files that contain an ordering element. Configuring beans. When a page references a managed bean for the first time, the JavaServer Faces implementation initializes it based on either a managed bean annotation in the bean class, or according to its configuration in the application configuration resource file. For information on using annotations to initialize beans, see Using Annotations to configure managed beans. You can use either annotations or the application configuration resource file to instantiate backing beans and other managed beans that are used in a JavaServer Faces application and to store them in scope. The managed bean creation facility is configured in the application configuration resource file using managed bean XML elements to define each bean. This file is processed at application startup time. For information on using this facility, see Using the Managed Bean element. With the Managed Bean creation facility, you can create beans in one centralized file that is available to the entire application, rather than conditionally instantiate beans throughout the application. Customize the beans properties without any additional code. Customize the beans property values directly from within the configuration file so that it is initialized with these values when it is created. Using value elements, set the property of one managed bean to be the result of evaluating another value expression. This section shows you how to initialize beans using the managed bean creation facility. See writing bean properties and writing backing bean methods for information on programming backing beans. Using the managed bean element. A managed bean is initiated using a managed bean element in the application configuration resource file, which represents an instance of a bean class that must exist in the application. At runtime, the JavaServer Faces implementation processes the managed bean element. If a page references the bean, and if no bean instance exists, the JavaServer Faces implementation instantiates the bean as specified by the element configuration. Here is an example managed bean configuration. Managed bean name, user number bean. Managed bean name, managed bean class, guest number. User number bean. Managed bean class, managed bean scope. Session. Managed bean scope. Managed property, property name. Maximum. Property name, property class. Long. Property class, value. 10. Value, managed property, managed bean. Using NetBeans IDE, you can add a managed bean declaration by doing the following. After opening your project in NetBeans IDE, expand the project node in the project's pane. Expand the web pages and web inf nodes of the project node. If there is no faces config XML in the project, create one as follows. From the File menu, choose New File. Select File, New File. In the New File wizard, select the JavaServer Faces category, then select JSF Faces configuration and click Next. On the name and location page, change the name and location of the file if necessary. The default file name is Faces Config XML. Click Finish. Double-click Faces Config XML if the file is not already open. After Faces Config XML opens in the editor pane, select XML from the sub-tab panel options. Right-click in the editor pane. From the Insert menu, choose Manage Bean. In the Add Manage Bean dialog box, type the display name of the bean in the bean name field. Click Browse to locate the beans class. In the Browse Class dialog box, start typing the name of the class that you are looking for in the class name field. While you are typing, the dialog will show the matching classes. Select the class from the Matching Classes box. Click OK. In the Add Manage Bean dialog box, select the bean scope from the Scope menu. Click Add. The preceding steps will add the Managed Bean element and 3 elements inside of that element. A Managed Bean name element, a Managed Bean class element, and a Managed Bean scope element. You will need to edit the XML of the configuration file directly to further configure this managed bean. The managed bean name element defines the key under which the bean will be stored in a scope. For a component's value to map to this bean, the component tag's value attribute must match the managed bean name up to the first period. The managed bean class element defines the fully qualified name of the JavaBeans component class used to instantiate the bean. The managed bean element can contain 0 or more managed property elements, each corresponding to a property defined in the bean class. These elements are used to initialize the values of the bean properties. If you don't want a particular property initialized with a value when the bean is instantiated, do not include a managed property definition for it in your application configuration resource file. If a managed bean element does not contain other managed bean elements, it can contain one map entries element or list entries element. The map entries element configures a set of beans that are instances of map. The list entries element configures a set of beans that are instances of list. To map to a property defined by a managed property element, you must ensure that the part of a component tag's value expression after the period matches the managed property element's property name element. In the earlier example, the maximum property is initialized with the value 10. Initializing properties using the managed property element explains in more detail how to use the managed property element. See Initializing Managed Bean Properties for an example of initializing a managed bean property. Initializing properties using the managed property element. A managed property element must contain a property name element, which must match the name of the corresponding property in the bean. A managed property element must also contain one of a set of elements listed in table 11-1 that defines the value of the property. This value must be of the same type as that defined for the property in the corresponding bean. Which element you use to define the value depends on the type of the property defined in the bean. Table 11-1 lists all the elements that are used to initialize a value. Table 11-1 sub-elements of managed property elements that define property values. Element value that it defines. List entries defines the values in a list. Map entries defines the values of a map. Null value explicitly sets the property to null. Value defines a single value, such as a string, int, or JavaServer Faces EL expression. Using the managed bean element includes an example of initializing an int property of primitive type using the value sub-element. You also use the value sub-element to initialize string and other reference types. The rest of this section describes how to use the value sub-element and other sub-elements to initialize properties of Java enum types, Java, util, map, array, and Java, util, collection, as well as initialization parameters. Referencing a Java enum type. A managed bean property can also be a Java enum type. HTTP. Download. Oracle. Com. JavaBeans. 6. Docs. API. Java. Lang. Enum. HTML. In this case, the value element of the managed property element must be a string that matches one of the string constants of the enum. In other words, the string must be one of the valid values that can be returned if you were to call value of class, string on enum, where class is the enum class and string is the contents of the value subelement. For example, suppose the managed bean property is the following. Public enum suit hearts, spades, diamonds, clubs. Public suit get suit. Return suit. Hearts. Assuming that you want to configure this property in the application configuration resource file, the corresponding managed property element would look like this. Managed property, property name, suit, property name, value, hearts, value, managed property. When the system encounters this property, it iterates over each of the members of the enum and calls to string on each member until it finds one that is exactly equal to the value from the value element. Referencing an initialization parameter. Another powerful feature of the managed bean creation facility is the ability to reference implicit objects from a managed bean property. Suppose that you have a page that accepts data from a customer, including the customer's address. Suppose also that most of your customers live in a particular area code. You can make the area code component render this area code by saving it in an implicit object and referencing it when the page is rendered. You can save the area code as an initial default value in a context initParam implicit object by adding a context parameter to your web application and setting its value in the deployment descriptor. For example, to set a context parameter called default area code to 650, add a context param element to the deployment descriptor, and give the parameter the name default area code and the value 650. Next, you write a managed bean declaration that configures a property that references the parameter. Managed bean name, customer. Managed bean name, managed bean class, customer bean. Managed bean class, managed bean scope, request. Managed bean scope, managed property, property name, area code. Property name, value. initParam. Default area code. Value, managed property. Managed bean. To access the area code at the time that the page is rendered, refer to the property from the area component tag's value attribute. H. Input text int equal area value equal customer. Area code. Retrieving values from other implicit objects is done in a similar way. Initializing map properties. The map entries element is used to initialize the values of a bean property with the type of Java. Util. Map if the map entries element is used within the managed property element. A map entries element contains an optional key class element, an optional value class element, and 0 or more map entry elements. Each of the map entry elements must contain a key element in either a no value or value element. Here is an example that uses the map entries element. Managed bean, managed property, property name, prices. Property name, map entries, map entry, key, my early years, growing up on 7. Key, value, 30. 75. Value, map entry, key, web servers for fun and profit. Key, value, 40. 75. Value, map entries, managed property, managed bean. The map that is created from this map entries tag contains 2 entries. By default, all the keys and values are converted to Java. Lang. String. If you want to specify a different type for the keys in the map, embed the key class element just inside the map entries element. Map entries, key class, Java. Math. Big decimal. Key class, map entries. This declaration will convert all the keys into Java. Math. Big decimal. Of course, you must make sure that the keys can be converted to the type that you specify. The key from the example in this section cannot be converted to a Java. Math. Big decimal, because it is a string. If you also want to specify a different type for all the values in the map, include the value class element after the key class element. Map entries, key class. Int. Key class, value class, Java. Math. Big decimal. Value class. Map entries. Note that this tag sets only the type of all the value subelements. The first map entry in the preceding example includes a value subelement. The value subelement defines a single value, which will be converted to the type specified in the bean. The second map entry defines a value element, which references a property on another bean. Referencing another bean from within a bean property is useful for building a system from fine-grained objects. For example, a request scoped form handling object might have a pointer to an application scope database mapping object. Together the two can perform a form handling task. Note that including a reference to another bean will initialize the bean if it does not already exist. Instead of using a map entries element, it is also possible to assign the entire map using a value element that specifies a map-typed expression, initializing array and list properties. The list entries element is used to initialize the values of an array or Java. Util. List property. Each individual value of the array or list is initialized using a value or no value element. Here is an example. Managed bean, managed property, property name, books, property name, list entries, value class, Java, lang, string, value class, value, web servers for fun and profit, value, my books, Bookit 3, value, null value, list entries, managed property, managed bean. This example initializes an array or a list. The type of the corresponding property in the bean determines which data structure is created. The list entries element defines the list of values in the array or list. The value element specifies a single value in the array or list and can reference a property in another bean. The null value element will cause the setBooks method to be called with an argument of null. A null property cannot be specified for a property whose data type is a Java primitive, such as int or boolean. Initializing managed bean properties. Sometimes you might want to create a bean that also references other managed beans so that you can construct a graph or a tree of beans. For example, suppose that you want to create a bean representing a customer's information, including the mailing address and street address, each of which is also a bean. The following managed bean declarations create a customer bean instance that has two address bean properties. One representing the mailing address, and the other representing the street address. This declaration results in a tree of beans with customer bean as its root and the two address bean objects as children. Managed bean name, customer, managed bean name, manage bean class, me company, my beans, customer bean, manage bean class, manage bean scope, request, manage bean scope, manage property name, mailing address, property name, value, address bean, value, manage property name, street address, property name, value, address bean, value, manage property name, customer type, property name, value, new, value, manage property, manage bean name, address bean, manage bean name, manage bean class, me company, my beans, address bean, manage bean class, manage bean scope, none, manage bean scope, manage property name, street, property name, null value, manage property, manage bean. The first customer bean declaration with the manage bean name of customer creates a customer bean and request scope. This bean has two properties, mailing address and street address. These properties use the value element to reference a bean named address bean. The second manage bean declaration defines an address bean, but does not create it, because its manage bean scope element defines a scope of none. Recall that a scope of none means that the bean is created only when something else references it. Because both the mailing address and the street address properties reference address bean using the value element, two instances of address bean are created when customer bean is created. When you create an object that points to other objects, do not try to point to an object with a shorter lifespan, because it might be impossible to recover the scope's resources when it goes away. A session scope object, for example, cannot point to a request scope object. And objects with none scope have no effective lifespan managed by the framework, so they can point only to other non-scope objects. Table 11-2 outlines all of the allowed connections. Table 11-2 allowable connections between scoped objects. An object of the scope may point to an object of the scope none, application session none, application session request none, application session request view none, application session view. Be sure not to allow cyclical references between objects. For example, neither of the address bean objects in the preceding example should point back to the customer bean object, because customer bean already points to the address bean objects. Initializing maps and lists. In addition to configuring map and list properties, you can also configure a map and a list directly so that you can reference them from a tag rather than referencing a property that wraps a map or a list. Registering custom error messages. If you create custom error messages which are displayed by the message in messages tags for your custom converters or validators, you must make them available at application startup time. You do this in one of two ways. By queuing the message onto the Faces context instance programmatically, as described in Using Faces message to create a message. By registering the messages with your application using the application configuration resource file. Here is an example of the section of the Faces config XML file that registers the messages for an application. Application, ResourceBundle, base name, Descriptor, web, messages, base name, var, bundle, var, ResourceBundle, locale-config, default locale. N. Default locale, supported locale, S. Supported locale, D. Supported locale, FR. Supported locale-config, application. This set of elements will cause your application instance to be populated with the messages that are contained in the specified resource bundle. The resource bundle element represents a set of localized messages. It must contain the fully qualified path to the resource bundle containing the localized messages, in this case, Descriptor, web, messages. The locale-config element lists the default locale and the other supported locales. The locale-config element enables the system to find the correct locale based on the browser's language settings. The supported locale and default locale tags accept the lowercase 2-character codes as defined by ISO 639 CHTTP. FTP ICS UCI EDU pub IETF HTTP RELATED. ISO 639. TXT. Make sure that your resource bundle actually contains the messages for the locales that you specify with these tags. To access the localized message, the application developer merely references the key of the message from the resource bundle. Using Faces message to create a message. Instead of registering messages in the application configuration resource file, you can access the resource bundle directly from NetBeans code. The code snippet below locates an email error message string message equal example bean, load error message context, example bean, X resource bundle name, email error, context, add message to validate, get client id context, new Faces message. These lines call the beans load error message method to get the message from the resource bundle. Here is the load error message method. Public static string load error message Faces context, string mass name, string key if bundle no try bundle equal resource bundle. Get bundle mass name, context. Get view root. Get locale. Catch exception return null. Return bundle. Get string key. Referencing error messages. A JavaServer Faces page uses the message or messages tags to access error messages, as explained in displaying error messages with the H. Message and H. Messages tags. The error messages that these tags access include the standard error messages that accompany the standard converters and validators that ship with the API. See section 2. 5. 2. 4 of the JavaServer Faces specification for a complete list of standard error messages. Custom error messages contained in resource bundles registered with the application by the application architect using the resource bundle element in the configuration file. When a converter or validator is registered on an input component, the appropriate error message is automatically queued on the component. A page author can override the error messages queued on a component by using the following attributes of the component's tag. Converter message references the error message to display when the data on the enclosing component cannot be converted by the converter registered on this component. Required message references the error message to display when no value has been entered into the enclosing component. Validator message references the error message to display when the data on the enclosing component cannot be validated by the validator registered on this component. All three attributes are enabled to take literal values and value expressions. If an attribute uses a value expression, this expression references the error message in a resource bundle. This resource bundle must be made available to the application in one of the following ways. By the application architect using the resource bundle element in the configuration file. By the page author using the f load bundle tag. Conversely, the resource bundle element must be used to make available to the application those resource bundles containing custom error messages that are queued on the component as a result of a custom converter or validator being registered on the component. The following tags show how to specify the required message attribute using a value expression to reference an error message. H. Input text int equals CCNO size equal 19 required equal true required message equal custom messages. Rec message. H. Input text. H. Message style class equal error message 4 equal CCNO. The value expression that required message is using in this example references the error message with the rec message key in the resource bundle. Custom messages. This message replaces the corresponding message queued on the component and will display wherever the message or messages tag is placed on the page. Registering custom localized static text. You can register custom localized static text with the application by using the resource bundle element in the application configuration resource file. Any custom error messages that are referenced by the converter message, required message, or validator message attributes of an input component tag can be made available to the application by using the ResourceBundle element of the application configuration file. Here is the part of a file that registers some custom error messages. Application, ResourceBundle, base name, gas number. Application messages. Base name, var. Custom messages. var, ResourceBundle, application. The value of the base name sub-element specifies the fully qualified class name of the ResourceBundle class, which in this case is located in the resources package of the application. The var sub-element of the ResourceBundle element is an alias to the ResourceBundle class. This alias is used by tags in the page to identify the ResourceBundle. The locale-config element shown in the previous section also applies to the messages and static text identified by the ResourceBundle element. As with resource bundles identified by the message bundle element, make sure that the resource bundle identified by the ResourceBundle element actually contains the messages for the locales that you specify with these locale-config elements. You can also pull localized text into an alt tag for a graphic image, as in the following example. H. Graphic image @ map image URL equal. Template. World. JPG alt = bundle. Choose locale use map = world map. The alt attribute can accept value expressions. In this case, the alt attribute refers to localized text that will be included in the alternative text of the image rendered by this tag. You can also use the f load bundle tag to load a resource bundle. This tag has attributes named var and base-name that specify the same values as the var and base-name sub-elements of the ResourceBundle specification in the configuration file. Using default validators. In addition to the validators you declare on the components, you can also specify 0 or more default validators in the application configuration resource file. The default validator applies to all input instances in the view or component tree and is appended after the local defined validators. Here is an example of a default validator registered in the application configuration resource file. Faces config, application, default validators, validator id, javax. Faces. Bean. Validator id, default validators, application. Faces config. Configuring navigation rules. Navigation between different pages of a JavaServer Faces application, such as choosing the next page to be displayed after a button or hyperlink component is clicked, is defined by a set of rules. Navigation rules can be implicit, or they can be explicitly defined in the application configuration resource file. For more information on implicit navigation rules, see Implicit Navigation Rules. Each navigation rule specifies how to navigate from one page to another page or a set of other pages. The JavaServer Faces implementation chooses the proper navigation rule according to which page is currently displayed. After the proper navigation rule is selected, the choice of which page to access next from the current page depends on two factors. The action method that was invoked when the component was clicked, the logical outcome that is referenced by the components tag, or was returned from the action method. The outcome can be anything that the developer chooses, but Table 11-3 lists some outcomes commonly used in web applications. Table 11-3 common outcome strings outcome 1, it means success, everything worked. Go on to the next page, failure, something is wrong. Go on to an error page, log in, the user needs to log in first. Go on to the login page, no results, the search did not find anything. Go to the search page again. Usually, the action method performs some processing on the form data of the current page. For example, the method might check whether the username and password entered in the form match the username and password on file. If they match, the method returns the outcome success. Otherwise, it returns the outcome failure. As this example demonstrates, both the method used to process the action and the outcome returned are necessary to determine the proper page to access. Here is a navigation rule that could be used with the example just described. Navigation rule, from view id, login. XHTML. From viewed, navigation case. From action, login form. Login. From action, from outcome, success. From outcome, to viewed, storefront. XHTML. To viewed, navigation case. Navigation case. From action, login form. Log on. From action, from outcome, failure. From outcome, to viewed, log on. XHTML. To viewed, navigation case. Navigation rule. This navigation rule defines the possible ways to navigate from login. XHTML. Each navigation case element defines one possible navigation path from login. XHTML. The first navigation case says that if login form, login returns an outcome of success, then storefront. XHTML will be accessed. The second navigation case says that login. XHTML will be re-rendered if login form, login returns failure. The configuration of an application's page flow consists of a set of navigation rules. Each rule is defined by the navigation rule element in the Faces config XML file. Each navigation rule element corresponds to one component tree identifier defined by the optional from viewed element. This means that each rule defines all the possible ways to navigate from one particular page in the application. If there is no from viewed element, the navigation rules defined in the navigation rule element apply to all the pages in the application. The from viewed element also allows wildcard matching patterns. For example, this from viewed element says that the navigation rule applies to all the pages in the books directory. From viewed, books. From viewed. A navigation rule element can contain 0 or more navigation case elements. The navigation case element defines a set of matching criteria. When these criteria are satisfied, the application will navigate to the page defined by the to-viewed element contained in the same navigation case element. The navigation criteria are defined by optional from outcome and from action elements. The from outcome element defines a logical outcome, such as success. The from action element uses a method expression to refer to an action method that returns a string, which is the logical outcome. The method performs some logic to determine the outcome and returns the outcome. The navigation case elements are checked against the outcome and the method expression in this order, cases specifying both the from outcome value and the from action value. Both of these elements can be used if the action method returns different outcomes depending on the result of the processing it performs. Cases specifying only a from outcome value. The from outcome element must match either the outcome defined by the action attribute of the command component or the outcome returned by the method referred to by the command component. Cases specifying only a from action value. This value must match the action expression specified by the component tag. When any of these cases is matched, the component tree defined by the to-viewed element will be selected for rendering. Using NetBeans IDE, you can configure a navigation rule by doing the following. After opening your project in NetBeans IDE, expand the project node in the project's pane. Expand the web pages and web inf nodes of the project node. Double-click Faces config XML. After Faces config XML opens in the editor pane, right-click in the editor pane. From the Insert menu, choose Navigation Rule. In the Add Navigation Rule dialog, enter or browse for the page that represents the starting view for this navigation rule. Click Add. Right-click again in the editor pane. From the Insert menu, choose Navigation Case. In the Add Navigation Case dialog box, from the From View menu, choose the page that represents the starting view for the navigation rule from Step 6a. Optional in the From Action field, type the action method invoked when the component that triggered navigation is activated. Optional in the From Outcome field, enter the logical outcome string that the activated component references from its action attribute. From the To View menu, choose or browse for the page that will be opened if this navigation case is selected by the navigation system. Click Add. Referencing a method that performs navigation explains how to use a component tag's action attribute to point to an action method. Writing a method to handle navigation explains how to write an action method. Implicit navigation rules. JavaServer Faces technology supports implicit navigation rules for faceless applications. Implicit navigation applies when navigation rules are not configured in the application configuration resource files. When you add a component such as a command button in a page, and assign another page as the value for its action property, the default navigation handler will try to match a suitable page within the application implicitly. Command button value equals submit action equal response. In the above example, the default navigation handler will try to locate a page named response XHTML within the application and navigate to it. Basic requirements of a JavaServer Faces application. In addition to configuring your application, you must satisfy other requirements of JavaServer Faces applications, including properly packaging all the necessary files and providing a deployment descriptor. This section describes how to perform these administrative tasks. JavaServer Faces 2.x applications must be compliant with at least version 2.5 of the servlet specification, and at least version 2.1 of the Java server pages specification. All applications compliant with these specifications can be packaged in a WAR file, which must conform to specific requirements to execute across different containers. At a minimum, a WAR file for a JavaServer Faces application must contain the following: a web application deployment descriptor, called web.xml, to configure resources required by a web application. An application configuration resource file, which configures application resources. A specific set of jar files containing essential classes, a set of application classes, JavaServer Faces pages, and other required resources, such as image files. For example, a JavaServer Faces web application WAR file using facelets typically has the following directory structure: $project dir web pages +- XHTML documents +- resources +- webinf +- classes +- lib +- web XML +- faces config XML +- glassfish web XML the web XML file or web deployment descriptor. The set of jar files and the set of application files must be contained in the webinf directory of the WAR file. Configuring an application with a web deployment descriptor. Web applications are commonly configured using elements that are contained in the web application deployment descriptor. The deployment descriptor for a JavaServer Faces application must specify certain configurations, which include the following: the servlet used to process JavaServer Faces requests, the servlet mapping for the processing servlet, the path to the configuration resource file, if it exists and is not located in a default location. The deployment descriptor can also specify other, optional configurations, including specifying where component state is saved, encrypting state saved on the client, compressing state saved on the client, restricting access to pages containing JavaServer Faces tags, turning on XML validation information regarding project stage, verifying custom objects. This section gives more details on these configurations. Where appropriate, it also describes how you can make these configurations using NetBeans IDE. Identifying the servlet for lifecycle processing. A requirement of a JavaServer Faces application is that all requests to the application that reference previously saved JavaServer Faces components must go through JavaX. Faces. WebApp. Faces Servlet. A Faces Servlet instance manages the request processing lifecycle for web applications and initializes the resources required by JavaServer Faces technology. Before a JavaServer Faces application can launch its first web page, the web container must invoke the Faces Servlet instance in order for the application lifecycle process to start. The following example shows the default configuration of the Faces Servlet. Servlet name, Faces Servlet. Servlet name, Servlet class, JavaX. Faces. WebApp. Faces Servlet. servlet class, servlet. To make sure that the Faces servlet instance is invoked, you must provide a mapping to it. The mapping to Faces servlet can be a prefix mapping, such as Faces, or an extension mapping, such as Faces. The mapping is used to identify a page as having JavaServer Faces content. Because of this, the URL to the first page of the application must include the URL pattern mapping, servlet mapping, servlet name, Faces servlet, servlet name, URL pattern, Faces, URL pattern, servlet mapping. In the case of prefix mapping, there are two ways to accomplish this. The page author can include a simple HTML page, such as an index. XHTML file in the application that provides the URL to the first page. This URL must include the path to Faces servlet, as shown by this tag, which uses the mapping defined in the guest number application. A ref equal Faces. Greeting. XHTML. Users of the application can include the path to Faces servlet in the URL to the first page when they enter it in their browser, as shown in the example below. HTTP localhost 8080 guest number Faces greeting XHTML. The second method allows users to start the application from the first page of the application rather than started from another HTML page. However, the second method requires users to identify the first page of the application in the URL. When you use the first method, users need only enter the path to the application, as shown in the following example. HTTP localhost 8080 guest number. In the case of extension mapping, if a request comes to the server for a page with a Faces extension, the container will send the request to the Faces servlet instance, which will expect a corresponding page of the same name to exist containing the content. If you are using NetBeans IDE to create your application, a web deployment descriptor is automatically created for you with default configurations. If you created your application without an IDE, you can create a web deployment descriptor, specifying a path to an application configuration resource file. As explained in application configuration resource file, an application can have multiple application configuration resource files. If these files are not located in the directories that the implementation searches by default or the files are not named Faces config XML, you need to specify paths to these files. To specify these paths using NetBeans IDE, do the following. Expand the node of your project in the project's pane. Expand the web pages and web inf nodes that are under the project node. Double-click Web XML. After the Web XML file appears in the editor pane, click General at the top of the editor pane. Expand the context parameters node, click Add. In the Add Context Parameter dialog, enter JavaX. Faces. Config files in the param name field. Enter the path to your configuration file in the param value field. Click OK. Repeat steps 1 through 7 for each configuration file. To specify paths to the files by editing the deployment descriptor directly, follow these steps. Add a context param element to the deployment descriptor. Add a param value element inside the context param element and call it JavaX. Faces. Config files. Add a param value element inside the context param element and give it the path to your configuration file. For example, the path to the guest number application's application configuration resource file is webinf Faces config XML. Repeat steps 2 and 3 for each application configuration resource file that your application contains. Specifying where state is saved. When implementing the stateholder methods, you specify in your deployment descriptor where you want the state to be saved, either client or server. You do this by setting a context parameter in your deployment descriptor to specify where state is saved using NetBeans IDE. Do the following. Expand the node of your project in the project's pane. Expand the web pages and web inf nodes that are under the project node. Double-click Web XML. After the Web XML file appears in the editor pane. Click General at the top of the editor pane. Expand the Context Parameters node. Click Add. In the Add Context Parameter dialog, enter JavaBeans Faces. State saving method in the param name field. Enter client or server in the param value field. Click OK. To specify where state is saved by editing the deployment descriptor directly, follow these steps. Add a context param element to the deployment descriptor. Add a param name element inside the context param element and give it the name JavaBeans Faces. State saving method. Add a param value element to the context param element and give it the value client or server, depending on whether you want state saved in the client or the server. If state is saved on the client, the state of the entire view is rendered to a hidden field on the page. The JavaServer Faces implementation saves the state on the client by default. Duke's Bookstore saves its state in the client. Configuring project stage. Project stage is a context parameter identifying the status of a JavaServer Faces application in the software lifecycle. The stage of an application can affect the behavior of the application. For example, error messages can be displayed during the development stage but suppressed during the production stage. The possible project stage values are as follows. Production development unit test system test extension project stage is configured through a context parameter in the web deployment descriptor file. Here is an example. Context param name, JavaBeans Faces. Project stage. Param name. Param value, development. Param value, context param. If no project stage is defined, the default stage is considered as development. You can also add custom stages according to your requirements. The project stage value can also be configured through JNDI. When using JNDI-based project stage, you need to configure the JNDI resource in the web deployment descriptor file. ResourceRef, resref name, JSF. Project stage. Resref name, res type, Java. Length. String. Res type, ResourceRef. Including the classes, pages, and other resources. When packaging web applications using the included build scripts, you'll notice that the scripts package resources in the following ways. All web pages are placed at the top level of the WAR file, the Faces config. XML file in the web. XML file are packaged in the webinf directory. All packages are stored in the webinf classes directory. All application jar files are packaged in the webinf lib directory. All resource files are either under the root of the web application resources directory or in the web application's class path beta-inf resources resource identifier directory. For more information on resources, see resources. When packaging your own applications, you can use NetBeans IDE or you can use the build scripts such as those built for Ant. You can modify the build scripts to fit your situation. However, you can continue to package your WAR files by using the directory structure described in this section, because this technique complies with a commonly accepted practice for packaging web applications.